Hi, this is Ed with LearnToC.org, App Inventor tutorial site. You've probably heard a lot in the news lately about something called the Intel CPU exploit. It's not specific to Intel, but that's how it was first reported, so people kind of referred to it that way. What is it all about? What does it do? And does this affect App Inventor and Android? And the answer is yes, it could. So let's first take a look at what is it. Well, it's actually two problems. One is a defect. It's not really a defect, actually. It's more a side effect of how modern processors are built. So probably a better term for it is exploit. One is called SPECTRE. That's the name given to it by the researchers who found it. And it actually affects many processors, not just Intel, but also AMD, Qualcomm, and ARM have indicated it could affect them as well in certain situations. It also affects multiple operating systems. MELTDOWN is the second problem, and it affects primarily Intel processors, probably. It could actually affect others, but it hasn't been verified yet. It also affects regardless of which operating system you are using. What do these exploits do? Well, what they do is they actually have, through some clever programming, a way that they can leak private memory, or what we might also call protected memory, such that an attacker could gain access to passwords, digital signature files, and encrypted private data. So, are you affected? Well, the answer to that is probably, but you probably don't need to panic either yet. SPECTRE does affect Android, Windows, Mac OS X, Linux, and iOS devices running on many kinds of processors. MELTDOWN may affect mostly Intel processors, and while it's been tested on processors going back to I think 2010 or 11, it may actually affect processors going back to as far as 1995. MELTDOWN's impact is actually to the processor itself, so it doesn't matter which operating system you happen to be using. So are there fixes available? For the most part, yes, there are. Intel has already released or is in the process of releasing various firmware updates, and software vendors have already made some operating system updates as well as some browser updates, because there's a version of SPECTRE that can actually run in JavaScript on an internet browser. Would put a little caution to this, and that is that while Intel has released some firmware updates to vendors, we may have to wait a while for computer makers to actually release those updates to us. What can I do about this? You might be thinking to yourself. Well, besides installing the appropriate updates as they become available to you, it's a good idea to always practice normal, safe computing practices. And what that means is do not install software from an untrusted source. That's a biggie. To use the SPECTRE or MELTDOWN exploits requires that someone first actually install malware on your computer. But if you practice safe computing, avoid installing untrusted software, you use firewalls and antivirus software and whatnot, you avoid phishing emails, and you pay attention to websites that try to do drive-by software installs, it's actually unlikely that such malware is going to end up on your computer. But do be aware, though, if it does, the SPECTRE exploit can theoretically be run from JavaScript inside a browser. And because of that, browser makers are also releasing updated browsers to counter possible attacks using the SPECTRE exploit. Google has released updates for Android, but some of us may need to wait for our smartphone or tablet manufacturer to release that code to us. Microsoft has updated Windows 10. Windows 7 and 8 fixes are coming very soon. There may be more fixes coming in future weeks as the vendors come up with better ideas on how to address it. Apple has already updated Mac OS X. Are all these fixes going to make my computer run a lot slower? And the answer to that is probably not. There have been some initial benchmark tests run by several groups or organizations, including Google, and they indicate that most applications will have generally undetectable performance impacts. There were some initial news reports suggesting everyone's computer might end up running slower by as much to 34% slower. And there may be some very special situations where that is true. But this does not appear to be true for those of us working on our own personal computers. What do these exploits actually do? It's kind of an interesting question. So what does this exploit actually do? How does it work? And we'll take a look at that over the next few slides. SPECTRE takes advantage of how a modern CPU processes the machine instructions and does this in an optimal fashion in a way that makes our programs run faster. Basically what it does is some very clever things that enables it to run some of our code possibly out of order from the way we wrote it, but still come up with the right answer. And in so doing, there's some tricks that can result in an application being able to basically do the equivalent of reading data in a protected memory area. And obviously that's something that's bad. We don't want that to happen. MELTDOWN works a little bit differently than SPECTRE, but it's a similar idea, is that the code gets executed potentially out of order, and this process can create some side effects. And it's those side effects that can leak some information about our data that our code should not ordinarily have access to. We'll now take a look at how SPECTRE operates. SPECTRE takes advantage of a technique that CPUs use called speculative execution. What that means is when we have code that does a conditional test, such as this idea of a statement here, if C equals 3, then do this, else do something else, the CPU may start running or executing the code of either the then part or the else part before it knows whether C is equal to 3 or not. What it has done is it actually makes a guess, and it can often do a pretty good job of guessing which way this is going to go. However, sometimes it will guess wrong, and when it guesses wrong, it has to go backwards and undo the work that it just completed. This can leave behind some detectable side effects. By detecting those side effects, an app can actually interpret what is being stored in some parts of memory that it shouldn't be able to see. Okay? So that's basically a simplified explanation of what's going on here. MELTDOWN has to do with how instructions are executed inside the CPU, somewhat similar to SPECTRE, but it's slightly different than SPECTRE. Sometimes when we write a program, it does not matter in what order a section of our code is executed. And the CPU may actually decide to rearrange the order of our program instructions as a way of optimizing the execution of the code. Because modern processors may be working on many instructions at once inside something called an instruction pipeline, a clever programmer could write malware instructions that do something the CPU maybe doesn't allow. And the CPU, though, will first start processing the correct instructions as they're going down this instruction pipeline. Then it will detect the errant code and stop the current set of instructions. However, some of the instructions ahead of it in the pipeline may have already partially executed, and those could have created some side effects. So when the errant code is detected, the CPU backs out the code it has run, but like with SPECTRE, it can leave behind some side effects that remain in the processor, and those side effects are detectable. Through some very clever programming, MELTDOWN can be used to read out most any memory on the computer, including and especially highly protected areas of system memory that might contain critical secret data such as a password or a digital signature or copies of encrypted data that has been unencrypted while stored in memory. Neither SPECTRE nor MELTDOWN reads protected memory directly. Instead, it's really a case of very clever programming that takes advantage of the side effects of speculative execution and out-of-order instruction execution. These tricks are used to speed up our programs. And that's something we like to have because we'd rather have our programs run as fast as possible. But if the CPU guesses wrong, as in the SPECTRE exploit, and it has to back out of the execution, or in MELTDOWN, where an errant instruction causes the CPU to stop processing for a moment because something's been done wrong, when it backs out of that situation, the CPU leaves behind some little side effects, and it's possible for clever programs to detect those side effects. And by setting up each of these scenarios of speculative execution or out-of-order instructions, it's actually possible to effectively glean information about very specific protected memory values, protected memory that our code should not have access to without authorization. I intend in a future video to take a look at what's going on under the covers, since when we program an App Inventor, we're generally unaware of the magic that's going inside our computer system or handheld device or tablet. So I'll do a future video that takes a look at computer system architecture and explains the basic idea of how a CPU works. We'll take a look at some of these modern CPU optimization techniques, such as speculative and out-of-order execution, so you'll get a better understanding of what's going on down there in the hardware of your system and how it's possible that this is not really a bug, it's a feature, but it's a feature that leaves open the possibility for some nefarious malware to gain access to information that it should not have access to.